Hello ladies and gents, welcome to another repair video. Today we're going to be working on a PlayStation 4 Pro which has been sent in, and this particular console has been sent in because it's had the 5-volt connector torn from the board. This is a repair that I see quite common. I believe I've got about 3 in the queue right now of this particular repair, but I thought I'd make a video, and there's 2 reasons why. Number 1, because I like making videos, and number 2 is because I want to try something new. So a lot of the time you'll see me talking about the 3 primary factors of a repair. Number 1 is functionality, number 2 is longevity, and number 3 is basically making it look good. So I want to try a new method today which I've been thinking about doing, and basically that's going to be to completely recreate the pad, so as basically if that connector ever needs to come off again, then someone's going to have the option to repair it without having to run jumpers. So I'm not going to be using those little copper traces that you saw on other channels because I think they are absolutely useless. They're really thin, they're no good for power connectors at all. But I'm going to be using some really thin jumper wire, and I'm going to try and basically thread a new trace. So without further ado, let's get into the video. But before we do that, if you are new to the channel, be sure to hit subscribe and turn on the bell notifications so that you're notified whenever I upload. Thank you. Alright, so as you can see, I've got the PlayStation 4 Pro here, and first thing I'm noticing is, number 1, the case is damaged. So obviously that's duly noted, but the case has been damaged during the initial disassembly. That wasn't me that's done that. This is the first time I'm taking this apart, but apparently the 5-volt connector has been damaged on this and it's going to need repairing. So usually what I would do is I would be able to get that open easier. But usually what I would do is I would just run some jumper wires, put some conformal coating over it and call it good. But I want to try something a little bit different, so it's a slightly different technique. I don't know if it's going to work, so I might look like a complete fool, or I could look like an absolute genius. Either way, I'm going to try it anyway. So I'm going to get this thing disassembled. It's kind of pointless trying to turn this on because I know what's wrong with it, and I know it's not going to turn on because the 5-volt connector is damaged. And this also came with this new cable. I assume it's a new cable, and if it's not, it's the old one. So it came with that as well. That was stuck to the top of it, and I don't know if that's the old one or the new one. If it's the new one, then the old one should be in here, but I don't see any reason why it would need changing, because it's the connector on the board which is damaged, not the connector for the ribbon cable, the one that goes from the power supply to the board. So I'm not really sure why it would need changing, to be honest. Here we go. Okay, this customer just got a little bit lucky. Well, that's assuming he's bought the right connector. Yeah, so this customer's just got a little bit lucky in the sense that I've actually got a board with that connector on. So I'm going to need to remove the connector. I'll show you how I'm going to do that in a minute, but first of all I need to clean up this mess. So, and I don't mean any offence to the customer by that, it is a mess. I'm not going to pretend it's not. So first thing I'm going to do is just desolder this wire. Okay, so I'll pop my donor board to one side. And let's take a look under the scope. And yeah, this is a mess. So these 2 pins here, well, the one of them is completely bent. So first question is, can I get that pin bent back? Probably not. I'm going to be honest, probably not. I don't think I can reuse this. I think it needs changing. I think that needs changing. Yeah. Okay, well, I think I'm going to need to text the customer and just see what he says, because that needs changing. That can't be reused. Yeah, that can't be reused. Okay, well, I'm going to text the customer and just see what he says. Right, actually, I am about to text the customer. I've just started writing the message, but I need to see what the state of this is first. So I'm going to have to clean this up. So I'm going to add some flux here, and I'm going to use some desoldering braid, so some wick, and that's basically going to suck up the solder and clean the pads. Wow, this is a bit of a mess. I'm not going to lie, I'm not going to pretend it's not. It's a mess. It's a big mess. I can't I can't sugarcoat this in any other way. This is a mess. Just dry that off. I need to work out what's actually going on with this. Okay, so the primary 5-volt trace is there. That's fine. So that is the primary 5-volt trace. And wow, that's multiple layers right there. That's multiple layers. And it's also fused the traces. So we're supposed to have 4 traces here. We're supposed to have one here. We're supposed to have one here, one here, and one here. And this trace has basically been scraped so far back, it's gone through layers. Wow. That's pretty bad. I'm not going to lie, that is pretty bad. Now, in terms of restoration, it's probably doable. It's probably doable. But it's not going to be easy, and I'm not going to be doing this at the same price as a normal repair. So I'm going to re-quote the customer. I'm not scraping back layers for £45. I'm sorry, but I just can't. I've got to scrape all of this back and make sure it's not going to touch these layers. And then I've got to protect all of that and run jumpers from the other side of the board and wrap them around the board to be able to have any chance of getting this working. So I'm going to have to re-quote the customer on this. I don't like doing it, but I'm going to have to re-quote the customer because this is not going to be a straightforward repair. So I'll pause the video and I'll resume when I've got a word back from the customer. Okay, ladies and gents, so I've just spoken with the customer and I've basically given him a new quote. Just for full transparency, I've quoted £75 for this repair. And the justification for this is the fact that, number one, there's a good chance that this has already been damaged beyond repair. Because I'm assuming it's been turned on. I'm assuming it's been turned on with multi-layer shorts. I don't know what this line is. I don't know what this line is, this one, etc, etc. I haven't got a clue. Because I've never had to dig through the boards. Or at least not here. So, I don't know what these lines are, and if we've had a short to ground on these lines, which we definitely have, then basically that could do anything. The last time someone did something this extensively, it blew the APU. It damaged the APU beyond repair. So no reboarding in the world would fix it. So basically, there's the fact that this has got a good chance of not working. And on top of that, I've got to sit here and dig through this. So I've got to sit here and dig through this to try and relieve any shorts that are there, and also to make sure that no shorts are going to present themselves in the future. On top of that, I've got to run jumper wires around the back of the board. I can't get to these wires where I would normally get to. So the jumper wires have got to go around the board, wrapped around, and basically over to where they go to on the other side of the board. That's no easy task on its own. And the reason it's no easy task is because we've got to find the lines. So I've got to sit there and trace them on a board where the connectors are not damaged. And on top of that, we've got the 12-volt connector here. This has got to be replaced. This cannot be reused. It's way too far gone. But you can see there it's got a really big kink. That is not going into the power supply at all. If it was down the bottom, fine, but that is not going into the power supply. And the reason for that is because this needs to be perfectly straight. What's happened here is the power supply has been pressed back down on top of it, and basically that has pushed it down. It's crushed it to a point where it's basically pushed and dug itself down here and then kinked back up, so it's folded back in on itself like this. And I can do this because I'm changing it anyway. So basically that's what's happened with that, and there is no way on earth that this connector can be reused. Maybe I'll be able to get it in once, but what about when this console needs to be cleaned in the future? It's going to snap. That is going to break in a minute. They don't take much. Just like that, and that's gone. So that would break there. I mean, you can see the true extent of this here. So I mean, this is no offense to the customer. I said this earlier. I don't mean any offense to the customer here. Hats off to the customer for trying. Hats off to the customer for at least trying to repair it themselves. But it doesn't look great. It doesn't look great at all. I'm going to give it my best. I'm going to try. Either way, this will make a video, but yeah, it doesn't look promising. I don't know what the outcome of this is going to be. I can't try that method that I was going to try because basically I can't get to the wires. So I need to start here by digging through this layer and basically just figuring out what can be salvaged, what can't be salvaged. So this ground pad here I don't care about, and I couldn't care less about this. So the reason that this is going to have had an internal short is because of the way the wires were actually soldered on. So if you think about how the wires were soldered on, they were soldered on something like this, and at some point that ground wire is going to touch that. When that connector was pushed back down, it's going to touch that. And even if this connector here was bent down and wasn't pushed all the way in, the 5-volt would still be live on the power supply side. So either way, 5 volts could potentially have gone through these lines, depending on which wires have been soldered, because I don't even know the orientation of the wires that were soldered. So potentially 5 volts could have gone through whatever line this is. I don't know if it's ground, I don't know what it is, but anything could have happened. And like I said, the last time someone damaged it to this extent and then attempted a similar repair, it blew the APU. I managed to restore the traces, and I had a blue light of death. A 2-second and then off blue light of death. So basically what I'm doing here right now is I'm digging all of this away. So I want to try and keep this one, this 5-volt one here. I mean, that wouldn't be too much of a problem because that goes to these capacitors here, I believe. That wouldn't be too much of a problem, but I want to try and keep that there so as I've at least got the 5-volt there, and then the ground I can run to any ground point. But the ground isn't a big deal, but the other two are. I believe one of them is marked up on the power supply as AC detect, and the other one I don't know. But they are needed. All 4 connections are needed in order to get this board working. So yeah, that's my justification for requoting this customer. Like I said, I wouldn't like to requote. I hate requoting. It makes me feel really, really mean. It makes me feel like I don't know how to explain it. It's one of those things where it just makes me feel really, really shitty, and I really do hate to requote customers. But in this case, it is absolutely justified, not only for the fact that we've got this damage here, but for the fact that we've got the damage to the 12-volt connector as well, which is more work on its own to replace. It's not a big job to replace it, and I've got plenty of donor boards where I can take one from, but it's still extra work, it's still extra time, it's extra parts, it's extra equipment. So for example, the consumables like flux and solder, things like that. So yeah, it's definitely justified, I think, in this case. But I'm basically just digging away this ground here. So this is all ground. Like this bit here, which I've dug away, is ground. So I can dig that away, and that's going to make sure that the ground isn't going to short out with the exposed traces. So let's just clean this up. Okay, so that's nice and clean. So what I need to do is I need to protect these traces, because like I said, I don't know what they are. It could be ground. It could very well be ground. I don't know. I can confirm that with the multimeter, but if it's a low impedance line, then it's going to come up as short on the multimeter anyway. So I may as well just not worry about that, and then if it's not ground, then it's not going to be in the back of my head, and I'll just focus on the repair instead. So like I said, either way I'm going to be attempting this repair, so no matter what that line is, I'm still going to attempt it anyway, just in case I can get it working. You know, even if it wasn't ground, I would still attempt the repair anyway, because I like to try. So what I've got to do is I've basically got to put some conformal coating on this. Now, conformal coating is pretty much what the green colour is here. This is conformal coating, solder mask, as we commonly call it. What that will do is it will re-insulate these exposed areas, and you cure this using UV light. You don't need much, you just need enough to be able to cover the area which you're trying to protect. We usually use this to hold jumper wires in place, but we also use it to recover exposed lines, exposed traces, exposed pads that we don't want to short out to other things. So basically I'm going to be covering this entire area. So all of this area which has been exposed, I need to cover, because if there's even one slight scratch, like for example I've just covered one, but I think there's one down here as well that you can't see fully. Even if there's one exposed piece of one tiny millimeter of exposed copper, if ground shorts out to it, it can short out a line. And because it's copper, it's conductive, and if it's conductive, it can short. If it can short, it can blow components, and if it can blow components, it can cause problems. So that is the reason that I'm protecting the entire area, or at least the parts which I know are not usually meant to be ground when the connector is on top. So I don't know what the layer is, like I said, underneath, and to be quite honest, I don't want to know, because it would kind of put me off the repair. But I just want to protect it. I just want to protect it. So basically, I'm gonna pretty much just fill this entire area with this stuff, and then I'm going to try and cure it using UV light. So this curing process is going to take a long time, because there's a lot to do. So it's going to take at least 5 minutes to cure all of this. Well, basically, I've just filled that entire area, and now I know that it's going to be protected, and that the jumper wires are not going to short out, and the pins on the connector are not going to short it out as well. So, epilepsy warning, I'm about to shine a light. So the light is going to change. If you are epileptic, look away for a few minutes. I will fast forward through this process, because like I said, it is time consuming. So all I'm going to do is just press the light. So 3, 2, 1. And I'm just going to keep running backwards and forwards with this light. This is a laser. It's a 405nm wavelength laser, and that's basically what the UV mask cures with. It cures on the 405nm wavelength. Okay, let's have a look. Let's see if it's cured. It has. Okay, so you can see now that instead of being liquidless, this is nice and solid. So what I need to do now is just scrape a little bit of this back. I know that seems counterproductive, don't worry. But basically I need to flatten it a little bit, because I want the connector to be as flat on the board as I possibly can. And obviously, if it's got a nice big lump in it, it's going to sit all wobbly. We don't want that. So I'll just scrape some back very lightly with the blade, with the edge of the blade, or what used to be a blade. It's now snapped. It's good for stuff like this though. That's why I don't throw this one. I've got another one of these knives, but I don't throw this one because it's good for stuff like this. It's good for digging. Saves me breaking blades all the while. So a bit of isopropyl alcohol. And of course, a random hair from somewhere. I haven't even got black hair, what the hell? Alright, so that seems a little bit better now. Seems to be a bit flatter to the board. And it's all still protected, which is fine. So that's good. So the next thing I want to do is just add some flux to each of these legs. So these are the legs from the 12 volt connector, in case you're wondering. I need to desolder this, but to desolder it I need to basically replace the solder with leaded solder because it's a big ground plane and it takes a long time to heat up. So I'm going to replace the solder. I've got myself a nice big tip here. I'll just replace the solder with leaded, and then I can wick the leaded solder away. So the lead-free stuff is going to take a lot longer to wick away because it's lead-free. It's got a higher melting temperature, whereas the leaded solder doesn't take that long. And if you're using the right tip, for example one with a big surface area, then you should be able to wick all of it away fairly quickly, or at least the majority of it. So these obviously have to take a lot of current, which is why they're so big. So I'm just going to scrape away until I know that most of the solder is gone. And I'll try and do the same with this one. Doesn't that look so pretty? Just sucking up that solder. This is Gootwick at work. This is £2 solder braid. I'm not sponsored by Gootwick, but £2 solder braid does that. It's really, really good stuff. It really is. £2 solder braid, and it can do that from a ground plane. So this is ground, by the way. If you're using the right tools, you can do anything. Okay, so that's the majority of that cleaned up and removed. So now if you look at the connector side on, there's actually a gap there, which is perfect because that means we can put something inside it and we can try and pry this off. So I'm going to pop a pry tool inside, and I'm not going to pry it off, don't worry, but I'm going to pop a pry tool inside, and then as I'm moving backwards and forwards with the soldering iron, I'm going to just basically try and pull the connector through, because I don't really want to use hot air because it's on the edge of the board, and on the edge of the board there's a good chance that you can damage the board. So I don't want to use hot air just because of that, and because most of the solder is gone, it should be fine. So you can see I've got my little prying tool here. This is actually my X-clamp remover for the Xbox, and I'm not going to put any excess pressure on this. Just bear this in mind, I'm not going to put any excess pressure on this. And this does appear like it's brute force, but these connectors aren't easy to remove. So I'm going to heat it up. And it looks like the soldering iron doesn't want to do it. I might have to use hot air, to be honest. But either way, I still need to lever it. Yeah, so the soldering iron, even with that big tip, isn't going to do it. So I'm going to have to use hot air. I don't like using hot air on the edge of a board, but needs must. So I've got my hot air set to 460 degrees Celsius. Okay, I can feel it starting to give. And there we go. It's a beefy connector. It's a very beefy connector. So, like I said, these are not the easiest things to remove. But there we go. That connector is now out. Throw that away. Flip the board around a minute. And what is that that was on there? Some sort of plastic. A little bit weird, that. I wondered what that was earlier. I didn't mention it, but there was something there. And I was like, what the hell is that? Has someone tried to glue this or what? I think it is actually glue. Well, not anymore, it's not. Alright, let's try and just heat that up a little bit. And at the same time, give it a little bit of a wiggle. Okay, now that's pushed through. Just add flux there. Okay, that's soldered. Nice. Nice. I told you this wasn't the easiest job to do. It might be through hole, but it's not easy. They are very big connectors and they're very weak. Alright, it's on a very slight angle. But I think it's fine. Okay, so next what I need to do is, well, first of all, get this big clump of flux off here. What is that? Where's that from? Alright, so, like I said then, I need to restore this connector. The connector will sit on the board like this. So basically what I need to do is I need to secure this down first and foremost. So I'll show you how I'm going to do that. Alright, so if you remember earlier, I was talking about basically weaving some new pads to create new pads for these traces here. That's not an option now. But what is an option is weaving some pads for the ground legs. So basically what we need to do is secure this connector in, and this, I will say, this isn't the same for all of the PS4 models. But what we need to do for this specific model to secure this in is to create a new ground pad. So I'm going to do that using jumper wire. And all I'm doing here is just scraping back some of this conformal coating so as I can expose the copper that's underneath. And then what I'm going to do is I'm going to solder some jumper wire across the ground pad and basically create a new pad. Or at least that's the intention. It's worked every time I've tried it in the past. Hopefully it's going to be the same this time. So I'm just going to scrape this back and just expose this copper, and then I can show you what to do next. So the problem here is that there's nowhere to anchor the connector down, and if we can't anchor the connector down, it's just going to be wobbling all over the shop. So we don't want that. We want to be able to actually secure it down, and that's where longevity comes into play, because if someone needs to take this apart in the future, then they don't want to be ripping the connector off. So next I'm going to add some flux all the way around. So I'll add some here as well. Get off my nozzle, please. Ugh. It's because there's still isopropyl alcohol there. Never mind. Okay, so next what I'm going to do is I'm going to tin this area which I've just exposed. So I'm just going to basically prep it so as it can take the jumper wire. Same with this here. And I'm also going to prep that pad. So now, like I said, I'm going to use some jumper wire to basically create a new pad. I could also use, and I'm actually going to try this because this might be easier, I could also use some wick, just a little bit of wick. So I've got here a little piece of wick. So this is the goot wick, the same stuff I was using to clean up the solder pads. I'm actually going to try this because I've never tried this, so it could work. So I'm going to put this in place. I'm going to hold it down. because this is exactly what I usually do, except I usually use jumper wire instead of wick. But this is basically a pad on its own. So let's just try this, shall we? So the solder's going to get sucked up, because solder loves copper and copper loves solder. This is innovation right here, ladies and gents. I never thought to do this. There you go. Look how strong that is. Oh, that's beautiful. I'm a genius. I'm an absolute idiot. Huh. Same with that one. Let's try that. Flood it with solder. Press down. I think that's going to work. What do you guys reckon? Let me know in the comments if I'm a genius or if I'm an idiot. And I think it's the latter. But I think that's going to work. I know that looks a mess, but it'll be fine once I've cleaned it in a second. Beautiful. Just dry that off. And now we've got some new pads. Look at that. Isn't she beautiful? So, I don't know if this is going to work, like I said, but it's definitely worth a try. But basically, you can see these metal points here, these metal contacts. Basically, I need to make a contact with that and then the board. That's just a anchor point, basically. So I need to make a point with that and the point on the board. So I'm going to need to add some more flux here. And I'm going to basically just apply some solder to the iron, if I can. Let's get loads and loads of solder on there. Let's get that in position. So we're going to make sure it lines up with our other pin. Oh, that's beautiful. Oh, that's beautiful. It really is absolutely gorgeous. Let's just make a contact with that pad. And I'm going to make sure that it's not shorting out. So I'm going to make sure that connector isn't shorting out with the ground, or rather that pin. I'm going to set my multimeter into continuity mode. And I'm going to make sure that we haven't got a continuous path from ground, so this point here, to this pin here. Nope, no continuous path. Isn't she beautiful? Oh, I love it. That's my new favourite trick. That is my new favourite trick, I'm not going to lie. So let's do the same for this side then. Beautiful. It's going absolutely nowhere. That is solid. Absolutely solid. So one thing I do need to do as well is I need to make sure that the pin that was there, the actual 5-volt pin, is making a contact with the pad. So the way I do that, if you look here, you can just about see the pad. So we've got no short to ground. Obviously there's a short there because that's all ground. So we've got no short to ground, but is it making a contact with the pin? Yes, it is. So that's soldered. So now all we need to do is run those other jumper wires and figure out where they've got to go to. So I've switched over to a smaller tip because obviously that tip was a little bit aggressive. And I'll just add a bit more flux there. I'll clean it all off afterwards. And I've got here some 0.1mm jumper wire. I know that sounds really small, but it's not so bad when you're under a microscope, I promise. So I've got some 0.1mm jumper wire, and what I'm going to do is I'm just going to tin the edge of this. I'm going to melt this flux so I can see. And then I'm going to tin these other 3 pins. I'll just add a bit of solder to them. Just like that. And then I'm going to solder a jumper wire to each of these pins. So the main thing we've got to make sure of here is that these jumper wires don't short to ground. They cannot short to ground, okay? We need to make absolutely certain of that. So what I'm going to do, I'm going to come pretty far here. And I'm just going to trim that wire in a random place. Because I know that I'm not going to need more than that. That's a fair amount of jumper wire there. So I know I'm not going to need more than what is there right now for that one. Because like I said, I've got to wrap these around the board. That's the problem. I've got to wrap them around the edge of the board. Which means before I do that, I need to put some conformal coating there. So I'm going to tin that wire as well. I'm going to solder that onto there. And then I'm just going to do exactly the same. I'm going to trim a random amount off, more than I'm going to need. And then I'm going to do the same for the other pin. The other pin is ground, so that can go on the top of the board. But it does need to be there. It is the only ground on the connector. The 2 anchor points are not in continuity with the second pin from the left, which means that until we actually ground this, the connector's not ground and it's not going to work. So run a jumper wire there, and that can basically just go straight to that ground point which I've just soldered. So that can just go to here, making sure once again that we're not shorting it out against the pins, but that can basically go there. And then that point there is grounded. So let's just make sure that we get a nice connection on these. And then what I'm going to do is I'm going to just clean up. So I need to be careful here because I've got the jumper wires here for the other 2 pins. I do need to trim that. I need to get rid of that excess. But I've got the jumper wire for the other 2 pins, which means I need to be careful that I don't pull it off. So I'm just going to go around with the toothbrush. I'll start with the back and the edges. And then like I said, I'm going to need to do the conformal coating, so it's going to need to be clean. So I've got to clean around this connector. It shouldn't pull it off with the toothbrush, but it might, so I do need to be gentle. Because otherwise I've got to put more flux on there, which means I've got to clean it again, which means it can possibly pull it again. It's a vicious cycle, trust me. But to put conformal coating down, this must be clean. It can't be covered with any kind of flux or anything because the conformal coating won't cure and bond with the board. Alright, so you can kind of get an idea of how these jumper wires are going to sit And obviously we can't have that because this is a ground here, this edge. That's a ground. We can't have that because it would short out. It would short out. We can't have it shorting out on ground because otherwise it's pointless putting that conformal coating underneath it. So what I'm going to do is I'm going to just lift these up really gently and just move them out of the way. So just throw them to one side basically. And then I'm going to put some more conformal coating underneath the connector. But first I'm going to make sure, once again, that we've got no short to ground. So I'll pop one probe on ground. And let's check these two connectors, or these two pins, and we don't have a short. And the end pin as well, and no short. Okay, so we've got no shorts to ground, which means that we should be good to put some conformal coating there and just basically secure this lot in. Because like I said, we need to wrap this around the board. Obviously once the board is back in the housing, we're also going to have the issue that the case is grounded as well. So we need to take that into consideration here. I basically just want to protect it, so as when I do wrap it round, it's not going to cause an issue. So this is going to give it that extra little bit of protection. There we go. That should be good enough. So I'm going to cue this once more. Epilepsy warning. 3, 2, 1. Okay. So that should be cured. Let's just double check. Yep. Awesome. Okay. So now, basically what I need to do is secure it some more. So when the jumper wires are wrapped around, it's basically going to cause pressure on the wire, and we don't want to end up causing the enamel to break and causing an issue later on down the line, because it could degrade over time and it could break away over time. You know, vibrations and things, even the slightest vibrations could cause that. So we're going to do the same again, only this time it's going to be to basically glue the wire onto the edge of the board. So not much is needed here, just enough to secure it down. So basically just like that. And the reason I've done it this way instead of just doing it all at once is because I wanted the conformal coating under the jumper wire, underneath the jumper wire, so as there's no chance of it shorting to ground. So the part that was exposed, I wanted conformal coating under that. So let's do that again. Okay, and again that should be secure. Let's just give it a poke. Nope, not quite. So you can see a little bit seeping out underneath. So what I'm going to do is I'm just going to push out any excess, and I'm going to cure it again. So I'm not bothered about it not being fully cured. It's literally just to stop it from scraping on the edge of the board here. So it's not to actually hold it down or anything like that. It's just to basically stop the wire from scraping the edge of the board and becoming grounded to the chassis, because the conformal coating has been exposed, or rather the enamel has been exposed. And now is going to be the not so fun part. So I need to figure out now where these points come out. So obviously it's difficult to pinpoint that using the multimeter and the pads. So what I like to do is basically solder a wire to the part where I want to figure it out. So if I want a donor board, I can solder a wire here, and if I tin the other side as well, and what I can do then is I can just probe the wire from the other side of the board and get a very accurate reading very quickly. I've got a rough idea, like I said, of where it's going to come out. I have done it before, but I can't remember. It's been a while since I've had to do this. So I'm going to trim off the wire. So I'm going to give myself a nice bit to play with here. So I'm going to leave a nice trail. There we go. And then if I flip the board around, it's basically going to come around like this. And what I want to do, like I said, is I want to pinpoint where it actually goes to. So I've got the wire here. So what I can do is just expose some of that wire. So just scrape a little bit of the enamel away, and that's going to make it conductive. So basically now I've got a connection on this side of the board where I can probe to figure out where the wire actually goes. So I'll leave that there. It's stayed nicely in place. And I'm going to pinpoint the location by touching this jumper wire here. I'm going to touch that, making sure not to touch ground or anything. And that comes out there. Whoops, I've just bent my probe. Well, it's inevitable. But that comes out there for that one. So pin number 3 is what I call that pin. So I'm going to mark that as pin number 3. Just here. So I know where that goes now. So now I flip the board back around and I just move that wire, same wire, just move that wire to pin number 4. And if I'm marking this, then I can use the board as reference when it comes to doing the work on the other board, because it's exactly the same board model. Now I realise that a lot of the time you're not going to be lucky enough to actually have that same board model. Notice how I move that then, because it was very close to touching ground. Obviously I don't want to probe a ground point, but I do realise that a lot of people are not going to have the same board. They're not going to be that lucky. I do get that. It is difficult. You know, all I can say with that really is a little bit of guesswork and good luck, basically. But now I know where pin number 3 comes out. You can see I can still see that. I know where pin number 3 is coming out. So let's find pin number 4. There. So I had a feeling that was there, which is why I went straight to them. I just didn't know which one was which, and I wasn't 100% sure. So basically, that's where they go. Pin number 3 to that one, pin number 4 to the other one. Basically now, I can run those test points straight to those points. So I'm going to start off with pin number 3, which is going to be this one just here. So I'm going to wrap that around like that, and I'm going to solder it just over here. Once again, we'll add some flux, and this is rather difficult now because I've got the connector on. I probably should have put the connector on last, to be honest, but I'm just going to tack that down so as it's in place, and then I can add some more solder and make a nice solid connection. I should have tinned those first as well. Whoops, I knocked it off. Never mind. There we go. So now I've got a nice solid connection. I can break the rest of that off, and I know that that's connected where it's meant to go. Same with number 4. That's going to go to that part, so to that test point there. I'm going to add some more solder, probably going to knock the wire off. Let's try not to. There we go. And it's a little bit further over than I'd like. I'd like it to be a bit tighter than that. There we go. Perfect. Well, maybe not perfect, but it's as good as it's going to get. That is going to be the best that I can do at the moment. It's not an ideal situation, but it should work. As long as no further damage has been caused, it should work. So I'm going to clean this up once again, and like I said, we're going to need to add some more conformal coating. Get rid of that fluff, we don't want that. And what we do want is more conformal coating. So again, I'm just going to add a layer of coating here. Just going to paint the board and just protect the work. There we go. Okay, this for the last time. I'm going to cure this mask. Yep, that's protecting enough. Okay, we're good to go. Finally, and that is ready to test. So I'm not going to clean it tonight. It's getting rather late. This repair's taken a little bit longer than I initially anticipated. I've been at this for a couple of hours now. Well, with breaks. To be honest, I had to contact the customer and things, so it hasn't taken me 2 hours. But I would say it's probably taken me around about an hour and 15 minutes, hour and 20 minutes, all in. But time wasted is time I could have spent doing other things, so never mind. Okay, so thermal paste has been removed. Let's add some fresh. So let's move the board a minute. So yeah, I'm not going to clean the housing out tonight. Like I said, it's getting rather late, so it's not going to get serviced tonight, but before it goes fully back together, it will be serviced. And if it doesn't work, then I'll make a follow-up video in the morning. Not tonight. Okay, so we've replaced the connector. So this 12 volt connector here. I've replaced this connector. We've run jumper wires. I've removed any potential shorts. And I've protected my work. And also, let's just admire once more how strong that connector now is. Probably stronger than it was when it come from factory. Probably stronger than it was. So let's just see what's going on. Does it have the right cable? Ah! Force of habit. Okay. Let's give it a go. That's making me kind of nervous. Not gonna lie, that's making me kind of nervous right now. I think this has got blue light of death. Oh wow, that sucks. All that work. Let me see if it's got a display. Very doubtful. Unless it's stuck in update mode. Very doubtful. Or is it the disk drive? Because that was trying to load on that disk drive for a long time. No. Oh, that's annoying. Nope. That's not going to turn on. It would have had a display by now. Let me just see if it still comes up PlayStation 4. No, it comes up HDMI 1, look. But then when I plug it in, it's recognising it's just on a blue light of death. Right, hello again ladies and gents. So, this is going to seem a little bit weird, but it's Sunday afternoon. So basically, on Thursday night I was working on the PlayStation 4, and as you'll remember from a few seconds ago, it had a blue light of death. So basically, I contacted the customer, I let him know, I said, look, it's got a blue light of death, unfortunately, it's a no fix. Wasn't going to charge him for it. He said, fine, I'll book in a collection for Monday. So it's Sunday afternoon, and I was putting the console back together this morning, and all of a sudden, it's working. Genuinely, it's working. And obviously, you can see behind me on the TV that it says can't connect to PS4. That's probably because of the amount of times it couldn't boot. But basically, I went to reassemble it this morning. As I always do, I at least try it before I call it done forever. Basically, it was getting ready to be packed up, ready for shipping tomorrow, and it's gone to a white light. I don't know if it was some sort of a short or some sort of a temporary intermittent thing, but when I took it all back apart and reassembled it fully, so as you'll see, if I just show you this, you'll have to excuse the mess. I'm working on other devices, so I haven't got autofocus or anything like that set up either. I'm working on another device. I'm just waiting on a PS4 to cool down. Well, it's cooled down, so I've just rebuilt the APU on this little puppy, and that's going into the ultrasonic cleaner in a minute, ready to clean and test. But yeah, I've been working on other devices, and that's why the bench is such a mess. But it's a work environment. It is what it is. But the console's working. Genuinely, the console's working. So I haven't even set up autofocus or anything, so you'll have to excuse that. But never mind. It is what it is. So while I was waiting for the board to cool down, ready to go into the ultrasonic cleaner, I decided to fully reassemble this and give it a test. And yeah, I honestly don't know. I can't explain it. As you can see behind me, it's working absolutely fine. Or at least it's turning on. I'm going to give it a quick test. But other than that, it seems to be working perfectly fine, and I honestly don't know what to say about it, because I don't know if it was just some sort of an intermittent issue, whether it was a temporary short or something like that. Maybe one of the jumper wires was shorting out on the chassis, but I can't see how that's the case, because the jumper wires were protected and still are protected with the conformal coating that I put around the edge of the board. So I honestly don't know. I really don't know why, but it does seem to be working now. Like I said, I do need to do some more tests on it, so I'll just quickly reboot it and make sure it actually boots into the operating system, into the dashboard. I don't know why I tried this micro USB cable, it never bloody works. Alright, let's see what happens. So I'll press cancel and just see if it wants to boot the software. Okay, so this should be turning back on right now. Let me turn this fan off. There we go. So we've got the PlayStation logo. I'm looking at it through my monitor, so I'm seeing what you're seeing. I'm seeing the camera. And yeah, it's booting into the dashboard. I honestly don't know what to say about this. It's really, really strange. But, I mean, yeah, it's crazy. It's crazy because it had a blue light of death and now it seems to be working perfectly fine. Let's make sure that we get controller sync. We do. Yeah, it's working fine. Let's check everything. Network. For some reason we've got no audio. Have they turned the dashboard sounds off? Checking network. Oh wow, system version 9. Okay. There's a new version out by the look of it. Test. I'm not going to update the system. So one thing I don't do unless a customer requests it is update the system, because it's not my job. Well, not in this case anyway. 190 megabits per second, so that's absolutely fine on Wi-Fi. Let's just make sure it's working in 4K. Sound and screen. There we go. System music was off. I'll turn that off just to keep it off. 2160p is working. Yep, it's working in 4K. Perfect. Just make sure that the disk drive works, because that's one test I always do. Okay, it's picking up that there's a disk in there. Not enough space, but it is reading the disk. Cool, fine, whatever. That's all good. It's working. I honestly don't know what to say about this one. This one was a troll. Yeah, so, well, I did do the outro, but I guess I've got to cancel that outro now and do some magic editing. But, yeah, that's going to be for this video. Obviously, this was pretty badly damaged, I'm not going to lie. It had a blue light of death after the repair. Don't know why. I can't explain it. I really can't. But this is the 4th or 5th time it's turned on and actually showed a white light now. I have been testing it all day. It's now, I don't know why I went like that. I don't know where I watch. I don't know. It's 4 PM. And I originally tested this at around about 11:30 this morning. And I've been turning it on and off between jobs. So I tested it about 11:30. Then I fixed an Xbox One X with no display. Then I tested it again. Fixed another Xbox One X with no display, which turned out really weirdly to have a retimer for an Xbox One S installed. Don't know. Anyway, and then I've tested it again. Then I've done this job, the PS4, reballed that, tested it again, and it's working absolutely fine. So I honestly don't know what to say. It originally come in for major damage to the power connector. We fixed that. Then it had a blue light of death. We've fixed that, and now it's working. But yeah, I hope you enjoyed this video. That is going to be it for this one. Thank you very much for watching. If you do have any comments or questions, of course, leave them down in the comment section down below. I always do my best to answer. And if you want to organise a repair, you can do so getting in touch using the website address in the video description. You can automatically book in the repair, or if you do want to get a quote first, there are prices on the website. But if you do want to get a quote, you can do so by contacting me using the Contact Us page. And I'll get back to you on that as soon as I can. If you enjoy this type of content, be sure to hit the subscribe button and turn on the bell notifications so that you're notified whenever I release a video. And if you want to support the channel, you can do so by becoming a Patreon supporter using the link in the video description. You can become a channel member using the join button below the video, or you can use some of the affiliate links where I'll get a little bit of commission when you buy stuff from Amazon, or Banggood as well. But that's going to be for this video. Thank you very much for watching. I am super glad that this is working, because now I don't have to eat dust for tea. But that's going to be for this video. Thanks very much for watching. Until next time, see you later. Bye for now.